we'll see the topic data transfer instruction in 8051. This is part 1. This topic is from chapter number 2, that is instruction set of 8051 and addressing modes. Myself, Dr. Kurnai Inamdar Faiz Ahmed, Head Department of Electronic Science, Abida Inamdar Senior College, Pune. Now, remember, any instruction given to the microcontroller consists of two parts. One is called as opcode and another is called as operand. Opcode means it tells the controller what to do. So it is operation code. Operand means that holds the data or information on which operations are to be performed. There are different types of instructions in 8051. One of them is data transfer instruction. It is used for moving data from one place to another place in the microcontroller. The data can be transferred between various memory storing elements like a register, memory location of RAM or ROM. Let's see first syntax, that is move a comma hash data. Its function is load the data into register A. Example, if your instruction say move a comma hash 55, meaning of this data 55 hex is loaded into register A. This hash sign indicates that it is a value. So anything after hash, that is 55, is nothing but a value. It is a direct value, or we can say immediate value. So A will be equal to 55H. Another example, move a comma hash 0F2H. So it will load data F2 into an accumulator. So A equal to F2. Now see here, whenever we have alphabet after the hash, that alphabet is not an alphabet, it is hex digit. So in hex we have A, B, C, D, E and F are as digit. So this 0 indicate that anything after 0 is the data and not an alphabet. That's why we always write 0 before any alphabet. If it is simple digit, no need to write 0. Another syntax is move rn comma hash data. This will load this data which is specified in the instruction directly into register rn. So this rn can be either r0 or r1 or r2 up to r7. We have total 8 registers, r0 to r7. This rn can be any one of them. One more syntax, that is move address comma hash data. Now here the address is indicating the memory address. So this will load the data into memory location pointed by an address in the instruction. So here it is rn, so data goes into rn. Here the data will be copied into memory location pointed by this address. So if we have moved 30h comma hash 55h, then data 55 will be copied in address 30h. Then next syntax is move a comma rn. Meaning of this, copy the content of register rn into register A. So here rn can be either r0 to r7, either of one. Example, one more syntax is move rn comma a. This instruction will copy the content of A into register rn. So both are opposite. Here content of Rn is copied into accumulator. Here the content of A is copied into an accumulator. This meaning of this. So for example, let A equal to, say, data is 33H and Rn is, say, data 41H. So when we give this instruction, move A comma Rn, so in A it will be 41H. So this content of RA will be copied in this. This is what meaning of this instruction. So this will copy the content of Rn into A. So here we have Rn 41 that goes into accumulator. Remember that value after hash symbol is loaded directly into register A or B or anything. So here you can see the example here. Here this data 23 is copied into A. Here data is only F9. This 0 indicates that F is the hex number and not any letter. So this 0 is indicator that F is an hex value. So this F9 will be copied in R5. One more thing, that if we write instruction move A comma hash 5 or write move A comma hash 05, it is one and the same. So hash 05 or 5 will be treated as A equal to 05. So here the value 5 is copied in accumulator. So here the A becomes 05. Same here A equal to 05. If we have value more than the limit, it will give error. We know that A is 8-bit register, so 8-bit will be only this much, either F2 or 7F. This is equal to total 12 bits. 7 is 4-bit in binary, F 4-bit to 4-bit, it is more than 8-bit. This is illegal, and then our system will give an error. So we can have data between 00H up to FFH. Now we have register R0 to R7, out of which only 2 can be used as a data pointer, and those are R0 and R1. So here you can see, and they are pointing an address of location with the help of this signal @. So here I am writing move A comma @R0, meaning of that go to the address pointed by R0 and from that address copy data into A. So writing move A comma R0 is different and this is different. Here the content of R0 goes into accumulator. Here this R0 @ this pointing an address of location. So if this R0 contains 30, so go at address 30H. So from this location, whatever inside that will be copied in accumulator. So it moves the content of RAM whose address is held by R0 into accumulator. Now here we cannot use register R2 to R7. Only you can use either R0 or R1. So you can have your move A comma @R1, that means copy the content of location RAM whose address is held by R1. So it is go at address pointed by R1, and that value is copied into accumulator. So here we have move A comma @R0. So you can see example here. This is move here. We let's suppose in A we have 05, R0 is 30. Meaning of this, in A move data pointed by R0. So go at address R30H into RAM. So whatever at address 30H, that data will be copied in accumulator. This meaning of this instruction move A comma @R0. If any queries, you can ask me on the mail.